So the question we get from our customers is why HPCC and not something else? It's the most common question that we get to ask. There are a few reasons, as you can see. Turn this down a bit. There you go. So it's open source. I think the most important part of HPCC Systems is that it's open source. That means you don't need to pay any fees for it. There are no contracting prices attached to it, anything like that. It's built to solve big data problems. So if you have a big data solution use case that you want to work out, HPCC is designed just to work on that. It's simple to use and maintain, and I'm going to cover this a little bit in the future slide, why we say it's easy and to maintain and to use. But one of the reasons about easy to maintain is because it's an enterprise quality. Reason being that if you're familiar with LexisNexis, you know it's a $7 billion business, and most of the products that supports LexisNexis as a company are actually generated from HPCC Systems. And because it is enterprise quality, the platform itself is constantly being maintained and upgraded. So at the same time, yes, it is open source, but it supports enterprise quality solution, and at the same time, because of that, it's being constantly maintained and upgraded. So let me start by just giving an example of how this solution is being used, the HPCC platform is being used. This is just a use case example from our company, so I'm just going to kind of talk about the story behind it. An insurance customer came to us and asked us about this use case that this story that they keep witnessing. They weren't so sure about why they observed what they were observing. So what they were observing was that you can see the blue circles being accidents, so accidents happening close to the hospitals, and each of these accidents had more than 2 or 3 people involved with it. So the insurance company was thinking, is it a case of a fraud? Do I need to be worried about this? But at the same time, they only had the amount of data they were looking at, and they couldn't actually figure out why they're seeing what they're seeing. And on top of that, they didn't have a technology to solve it. So they came to us and said, we're seeing all these accidents happening, but we can't tell why it's happening. So what we did is we got their data, and we used some of our in-house data, and then we layered all of them together and tried to combine them, use our data linking solution that we have in-house, and then we realized that these accidents are actually happening by a large group of friends and family. So basically, families and their friends would get together and say, oh, we can do this. So they would fake this accident so they could claim insurance and get money out of it. And then they realized that, yes, these are all the insurance fraud that is happening. And we did this by using the data that the insurance company gave us. We used our social networking graph, which I cover a little bit in a minute. And then we decided that, yes, this is a case of a fraud. So let's talk about a little bit how this platform actually came to life. Back in 2001, a company approached us and then told us that they're trying to solve a problem, which is they wanted to predict by the start of the month how many customers would claim bankruptcy throughout the months. What does that mean? It means that if we're in February 1st, and then we wanted to decide how many customers for the month of February would claim bankruptcy, how do we figure this out? The company itself had a solution, but the solution they were using were taking 25 days to solve that problem. So they approached us and said, this is a problem, we want to solve it. The problem, the 25 days means by the time we reach the end of the month, you already know how many customers are going to claim bankruptcy. So that solution was almost useless to them. So what we did back in 2001, we gathered a bunch of SMEs together. We hired a few contractors, and then they developed HPCC Systems. So it was originally designed to solve big data problems. And that's how we were able to solve this customer's problem and bring the number of the days that was 25 days to solve a problem down to less than 4 hours. And this is how we decided that HPCC is a good solution to solve big data problem. Fast forward to 2007, we acquired we acquired ChoicePoint, which is a big data insurance company, had a lot of data, but they were running into similar problems that the customer I just talked about had. They had Oracle, they had their own mainframe, but the process of the data was taking too long for them. So after we acquired the company, it took us 4 years to move their data over to HPCC Systems, and then we started using it and maintaining that data. Then in 2011, we decided that, yes, we are an enterprise company, and we use HPCC system to solve all these big data problems, but we wanted to get the community feedback for it too. We want to make sure that other people have access to this platform and they can use it. And this is when we decided that we want to go open source, and we went open source under Apache 2. And this was a good decision for LexisNexis, making this open source, because since then external customers are able to implement this into their solution and use it for the use cases, big data use cases that they have. At the same time, a lot of colleges are using this. It's being used in their research projects, and communities, individuals are able to download this platform and then start using it, solving their big data use cases, as you say. And then we start evolving and growing. Fast forward to now that we are having a solution under Kubernetes, which is deployable to cloud, AWS, and Azure. So as I said, it's maintainable and being upgraded constantly. So we are emerging and evolving as the technology is growing. So in the example that I talked about earlier, I talked about getting the insurance company information, which they were suspicious of fraud happening. And I said we use our data to kind of link all these data together. So when we talk about data linking, exactly what that data linking means. Data linking means that I want to get a complete 360 view of a person. So if person A is in question, I wanted to know everything there is about person A. How do we do that? We start by getting information on person A and understanding what are the assets, what are the belongings of this person, what's the name of this person, and then we start linking these together. A good example would be if this person owns a property, then we have the property address, and by property address, we can decide if there's anybody else that lives in the same house with this person, and we can link it to other person, and that other person has other assets that can be linked together. Once you have all this data, then you send it through data pipeline, which is cleaning it, profiling it, enhancing it, and then you have a complete view of a person in question. And data linking is not just about the person in question. It could be about anything. It could be about the house. What are the information we can get about this house? Or it could be about in agriculture, farming, owning a stock and getting all the information about soiling, weather system, the food that the animal are eating, things like that. Once you have this data together and link it together, then you have an accurate data that could help you solve your problem. In this result of the data that you have can be used for analytical work, to make business decisions, or in the example that I showed, to decide fraud. LexisNexis happens to have a lot of data, which comes from DOI, bankruptcy, government. As a joke, when people ask me what kind of data you work with, I always say, you name it, we probably have the data. And this is how we're able to link these data and make a perfect view of the subject in question. We don't get that data from social media. So we don't get to, for example, to Facebook and LinkedIn and say, oh, this person is claiming to be in relationship with this other person. No, we bring data accuracy to our customers using HPCC platform and linking all these data that we have together to get a complete and accurate vision. Okay, so I talked about the use cases we have and what we do with the data that comes to play. But what is this HPCC made of? What is this infrastructure made of? What you're looking at is the overall view of the HPCC systems. As I mentioned, we get a lot of data from different resources, and the HPCC is capable of handling structured data, unstructured data, semi-structured data. And as you look at it, it kind of has a funnel-shaped thing. So the data comes in as in a big quantity, I want to say. And then this data could be in different formats, from Parquet to CSV to JSON. This platform has the capability to dealing with different shape or form of the data. Then it comes into our Thor environment. Thor environment is our data refinery environment. So it does all the ETL, all the expensive data handling, shaping the data, linking the data, which I just covered a little bit, cleaning the data, and enhancing it. Once it does that, then data is ready to be delivered for analytical reasons, for real time, for batch processing, anything you want. It can be done after it's gone through that data lifetime processing. So if you have customers that want batch result, all you have to do is, once the data is done, you can just use Thor to send the result out to the customer. But if you have real-time customers, then Roxy comes to play, which is our data delivery engine. So basically gets a snapshot of your data and has the capability of rapid data delivery. This is where your real-time or near real-time customers can benefit from. That result can also go to data analytics for machine learning and anything you want, APIs. All of these things can be handled by this cluster. One of the good things about looking at this is that everything happens in one solution. So once data enters your system, it doesn't need to go to environment A or B or C for different type of processing. The benefit you get from that is that when it comes to security and governance, you don't need to worry about every time you move the data, what happens to my security, what happens to the data governance. Once you set the system up, you have the answer to all of them. And then at the same time, you're saving time and cost because you're not constantly moving your data around for different purposes. So I talked a little bit about what the platform looks like. From the minute data comes in, it goes through our Thor environment, as I said, for data processing, data enhancement, data linking, and then it goes to Roxy or API calls based on the customer's need. This slide basically talks about what are the key features of HPCC systems. As I mentioned, the HPCC systems is capable of handling any shape or kind of data. It's a schema on read. It basically means you don't need to worry about the shape and layout of your data until you want to use it, which is a data lake definition. HPCC is the exact same thing. You don't need to worry about what your data looks like until you want to use that. I mentioned between Thor and Roxy, HPCC gives you the chance or the option of being able to handle batch processing, real-time, or streaming data. Here's my second question. Can anybody guess what ECL stands for? Anyone? I tell you this one. It actually stands for, ECL stands for Enterprise Control Language. That's the language that we use to be able to do all the data processing and handling that I mentioned. The benefit about this is that ECL is data-centric. It's similar to SQL, so if you know SQL, understanding ECL is very easy. And the way ECL works is that you basically need to tell what you want to do with your data. You don't need to worry about how you want to get it done. You just worry about what you want to get done with it. And the ECL language is used both for Thor and Roxy. And as I mentioned earlier, this is, HPCC is cloud solution as well. So if your solution is sitting on cloud, you can use AWS or Azure because we have it under Kubernetes. So in this one, we're just showing you how the data is going around when it comes to the solution. So big data comes to play. The dotted box that you're looking at is your HPCC platform. As I mentioned, we have Thor cluster and Roxy cluster or engine, Thor being the data refinery and Roxy being data delivery, and ECL is a language that can get used to code in both languages, in both engines, I'm sorry. And then the VS Code is basically our Visual Studio Code that all you have to do is download the HPCC plugins, and then you can start writing your ECL code. And then the result, once it's ready, it goes out to be queried, visualize, or use API to send it to someplace else. This is a very self-explanatory slide. So it's basically wanted to show you how much of the data and in what magnitude of data this platform can handle and process. One of the main things is that, as you can see on the Roxy column, is that it can do 200 million Roxy calls per hour, which basically you're talking about several thousand calls per second. So if you have a customer in an enterprise format, you can do several thousand callers, real-time calls, and customer can get the data as they need it. We also have like 400 node Thor engine that use data distribution and data parallelizing, so that would expedite the data, data processing for it. So this one is just showing how much of capable of this platform is when it comes to processing your data. Having said that, it does not mean that the only way you can use HPCC is to have petabytes or million rows of your data. No, that's not right. You can work with a smaller data size that you have. Let's say you're a startup. You can use a smaller data set, and you can use HPCC to do that. You don't need to have a cloud solution. You can basically go to the website, download HPCC on your laptop, and work on it on a smaller scale. One of the major points of HPCC is being scalable on top of being accurate because of all the data processing that it can handle and the speed, because as I'm showing, we can do rapid data delivery. One of the things is scalable, so it can work with a person of one trying to solve something small on their laptop to an enterprise quality solution that wants to work with petabytes of data. So I'm going to touch a little bit on the cloud ones. So the way our cloud solution works, as I said, it's using Kubernetes, and it's deployed using Terraform and Helm. One of the advantages that I like about this is that everything, as you know, I don't know, is everybody familiar with Kubernetes or no? Good, I love the nodding. I don't need to do a lot of explanation. So everything is being deployed as a pod. Thor, as I said, is our data refinery engine, so it uses a lot of processing. One of the benefits about that is that when a user submits a job, they don't need to worry about, what happens is that Kubernetes takes a look at the size of the job and assigns some pods to get the job done. But because we want to always save cost and time, after the job is completed, those pods aren't instantly released. Kubernetes listens to see if there is a next job coming in, and if there is, it will hold on to the pods to execute the next job. This way, every time you run a job, you don't need to release that and then assign again, which would waste time and money. So let's talk about the language a little bit. I said ECL is the language we're using. It's declarative. As I said, you don't need to tell how you want to get it done. You just say what needs to get done. And the column you're looking at, if you're familiar with SQL or Panda, you can kind of compare the commands for them. Collection is basically defining the layout and the format of your data. Join in SQL and ECL are very similar. You can do inner join, left outer, left only join. And then aggregation, if you want to do like grouping it and understanding the maximum, minimum, that's where data aggregation comes place. I think that one of the interesting things in ECL is that if you look at the last row, you realize that we don't have a for loop or a while loop. We have project. So instead of telling the platform where to find it and which row or which column we are after, we can just write a project that goes, grabs the entire data set and runs through every row at a time, and then does the processing that you wanted to get done on your data. So this is a very simple, small example of how a join would be written in ECL. I'm going to make my screen a bit bigger so I can read it and tell you what actually is happening here. The first few lines, as I said, the first thing we want to do is a schema on read. We want to define the layout or the schema of our data. So the color rec basically saying, this is the schema, the layout of my first data set. For the sake of this example, I'm just using inline data set. So colors DS is an inline data set. If you have a file, all you have to do is remove all those curly brackets and just put your file name here. So that's how you use a file that has rows and rows of data, whereas a very small data set that I just wrote for this example. Then you have the color code rec2, which I'm defining the schema for the data, and then I'm defining the elements of my data, and then I'm trying to read it. Color resrec is actually me saying, what is my output supposed to look like? So I'm joining two data set. What is the final data set supposed to look like? And then join is basically saying, if the left color ID of my data set, which is basically my left data set going into the join, is matching the right data set with the ID field, go ahead and do the following. Transform is basically a simple function that you can use to say how I want this data to be joined and what my field's supposed to look like. And then the picture basically showing the two data sets going in your left and right, and then the blue table on the bottom is showing the result of the join. Okay. ECL watch page is our real-time online management interface. It gives you some administration access. This is a great tool for ECL developers, comes with the platform, is integrated into the platform, and it gives you administration system. So if you have an admin, they can go in, they can try to tighten up the security, give user access, group access. They can modify the security access for the files you have on the platform. But at the same time, it does give developers a good helping tool for taking a look at the jobs they're running, the output, what are the inputs that went to that job, how long time it took to complete the job, how much did it cost to run that job. All of those information can be found through ECL watch page. So it's a very, very handy tool that can be used by admin or an ECL developer. One of the major part of the ECL watch page is actually the compiler. The compiler of HPCC system is actually written on C++, but compiler is a smart compiler. So one of the things that it does is when a developer submits a job, it takes a look at the job and decides what is the best way to run this job to save money and time. So it basically looks at everything and says, oh, the developer wants these three items to be done. But if I run it the other way around, they will get the result faster. An example would be if an ECL developer comes in and says, sort this data set and filter it, sort being an expensive functionality, compiler is going to say, no, I'm going to filter it and then sort it to save you cost. One of the other things that the compiler offers is basically gives you warnings. So a developer can go take a look at those warnings and figure out what's wrong, what they can do to actually improve the code that will help the execution time and hence the runtime cost. And at the same time, as you can see in the graphs that I'm showing, you can take a look at like the skew time, the execution time, and a developer can go back and modify the code to get better runtime. So We have some integrated tools and have some complementary tools when it comes to HPCC systems. The ACL watch page I already covered. The VS Code I already mentioned that all you have to do is download a plugin and you can write the ECL code. And the GitHub, the Gitpod ID is basically your VS Code and your browser. So everything is in one package that you can use. And then we have data profiling, which lets you understand the shape of your data. You can run it either on the ECL watch page, or you can write code for it in the VS Code, and that gives you an idea of when you have a brand new data. That helps you take a look at the data and figure out what are the rows that have information missing, where are the areas that you need to focus on to improve your data, and data profiling gives you that capability. We also have complementary tools. RealBI is our Roxy-enabled business intelligence. That's basically our data dashboard visualization tool. One of the benefits for both RealBI and Tombolo is that they actually connect to the platform, to the cluster that your data is located. So even if you want to do data catalog through Tombolo, or if you want to do data visualization through RealBI, you don't need to change the format of the data and ship it elsewhere to do all of these things. All you have to do is go to these tools and point to the cluster that your data is sitting and say, do the following for me. And then data catalog, as we probably all know, it covers the data catalog features, but at the same time, it allows you to kind of monitor your ECL, your cluster too, so you can take a look and see how much space you use, how much you have left. You can set up like monitoring for the jobs and the files, and then decide if the size of the file is moving, you get an alert. If the ownership using, you can get an alert, and similar things that comes with Tombolo. So, before I go any further, because we're almost at the end of the time too, I'll ask my second question. Anybody remember what Thor did?
Process the data.
Yeah. And anybody remembers what Roxy stand for or did? Go ahead. I'll let you do the distribution. Well, I have two more, so we still have chances here. So as far as supporting training, HPCC support offers a lot of documentations. Being a bare metal, being in a cloud solution, we offer a handful of trainings and documentation that can help you if you want to run it in any different environment that you want. If you want to learn the language itself, we have all those. We also have trainings available. Some of them are free. Some of them, if you can find the promo code, which I want to say they're kind of easy to find, you basically can learn the entire language without need to pay anything. So I just want to talk a little bit about my team. As I said, I'm a solution engineering manager. My team works with the customers that they're interested in working with their big data solution. So if you have any questions, if you want to try a POC using the HPCC systems, you can contact me and we can talk about the specific use case you have and help you set up a POC if you're interested in learning. Keep in mind as a summary that the entire thing that we talked about today is open source. So we're not selling anyone anything, and we're not trying to bind a contract here. And the system is scalable. It doesn't matter how big the data is or how small the data is, HPCC can handle it regardless. And we can go from anything from bare metal, being your laptop, to a cloud solution. So if you're interested and you have further questions for this, you can contact me.